previous class we have derived both the derivations on for maximum bending stress we have solved for K method and principal axis method. Today we can solve a problem related to K method. Already we have derived the formula for K method. Using that formula I am going to solve the problem. You can remember this formula that we have derived in K method. Okay, this is the bending stress, this is moment about x, this is moment of inertia on y axis, this is moment about y, and this is moment of inertia about xy axis. This is x and y coordinates. Using this formula we are going to solve a problem. Okay. Please take down the question. Find the bending stress for the given cross section using K method. Using an unsymmetrical T section, we are going to solve this unsymmetrical T section using K method. The given data are the dimensions here. Take mx value 2000 Newton meter and moment about y value 1000 Newton meter. Please take down the question. Here see, we have to find out the maximum bending stress. For that we should, this is the formula for finding the maximum bending stress. For that we have to calculate moment about x and moment about y. See, in the question itself they have given the moment about y and moment about x values. So we no need for calculating the moment values. Okay. You have to know the moment of inertia Iyy value, moment of inertia Ixx value, Ixy value, Ixx value we have to calculate. And x and y are nothing but the coordinates of any points. Okay, let us consider this is A, this is B, C, D, E, F, G. Like this way we can take it as coordinates. If we apply the xy coordinate value for A, for this x and y values, you will get the maximum bending stress at particular point A. Okay, can you understand? So this is how, only thing we have to calculate the moment inertia of Iyy value and Ixy value, Iyy value and Ixy square value. This is the three values we have to calculate. Other things are the known values. Moment about x, moment about y. For solving that, I am going to draw this diagram once again. This unsymmetrical T section. This is the unsymmetrical T section and here is the axis. They have given the dimension, thickness of this T section is 8 mm. And the height is 80 mm. This is 40 mm. This one is 80 mm. Okay, these are the dimensions they have given in the question. You can see here. Okay, these are the dimensions they have given. First, initially for calculating moment of inertia, I have to calculate the CG for this particular T section. What is CG? The total force is concentrated on a particular point in any object. Okay. For a symmetrical section, you can easily point out the CG location. Consider this is a square. In this, what is the CG location? You can easily point out this is the CG point. If I take this square in this particular point like this way, if I take this, the whole forces will be concentrated and it can balance in that position. That is known as CG point. Okay. For in case of unsymmetrical section, I can't point out where is the CG point, where the center of gravity is fully concentrated in this particular point. So I have to calculate the CG for unsymmetrical section. Look, this is the given data is an unsymmetrical section. So I have to calculate the CG. CG may be somewhere here or here. I have to calculate the CG point. Okay. How to calculate the CG? Already in strength of materials you might have calculated, I think. So before calculating CG, I am going to make this T section in an XY plane. Okay. For that I am going to draw consider this is the origin, and this is X axis and this is Y axis. Okay. This is the origin where the point is 0, 0. By taking this as origin, I am going to solve this problem. Consider this may be the CG point, which is X bar, Y bar. We have to find out the X bar and Y bar value. What is the formula for CG? To calculate CG for X bar, to calculate CG, X bar formula is A1 X1 plus A2 X2 by A1 plus A2. What is A1, A2? Initially, for calculating CG for this type of unsymmetrical section, we have to subdivide this into two sections. Section 1 and section 2. A1 is nothing but area of the section 1. A2 is nothing but area of section 2. Calculate section 1 area. Section 1 is like a rectangle. So length into breadth is the area value. Okay. Area A1 is equal to 80 into 8. It is a rectangle, so I have subdivided this into two sections. This is one section and this is other section. Okay. For area 1, 80 into 8 If you calculate that, 640 mm square area 1 value. For area 2, here we are having the length 40 plus 80, that is nothing but 120 mm, and breadth is 8 mm. Which is nothing but 960 mm square. So we have calculated the area A1 and A2 values. We have to calculate x1 and x2 value. What is x1 and x2 value? This is the xy axis line, and how much distance each sections, or how much distance from this axis we have to in both x and y plane. By considering the x and y axis, we have to consider this section is how much distance from this plane. We have to draw the neutral axis. Okay, see, this is the neutral axis for this section 1, and this is the neutral axis for section 2. And how far the x plane is distance from this, for when we consider this section 2, how far the neutral axis is distance from this x plane, and for considering section 1, how far the neutral axis is distance from the y plane, y axis. We have to calculate this distance, that is the xy value. See, first I am going to calculate x1 value. X1 is for section 1. So how much distance is from this y plane? From the origin, the neutral plane is how much distance for x axis, for considering x distance. X1 resembles to section 1. Okay, we have to measure the distance between neutral axis and the normal plane. So between neutral axis and normal plane, what is the distance? This is 40 mm. You can see this is 40 mm. Okay, so for x1 value I am going to give 40 mm. For writing x2 value, how to calculate x2 value? X2 value is, we have to consider the section 2. Okay, for section 2, what is the x2 value? How to calculate x2 value? You can see this is the midpoint for this section 1. When considering this T section, for section 2, what is the midpoint from this axis? You can see the total distance is 40 plus 80, 120 mm. Okay, what is the midpoint from this reference plane? 40 plus 80, 120 mm. When you divide by 2, this is the midpoint for this section 2. Okay, so for considering section 2, 40 plus 80 by 2, which is nothing but 120 divided by 2 is equal to 60 mm. This is the x2 value. The midpoint for this, in case of x reference line, it is 60 mm from this for section 2. Okay, you can write 60 mm. Now calculate this x1 bar value. We are having all the values. Okay, a1, a2 and x1, x2 values we have calculated. The x bar is equal to, what is a1 value? 640 into x1 value I have calculated as 40 mm. 40 plus